So I'm going to continue a little bit from here and hopefully be able to put those two videos together. I had an alarm that woke up, or that went off. Anyway, let's continue. So I substituted 1 here and here. And then I said 1 to the 1/2 power is going to be 1 still, because the square root of 1 is 1. And I'm not introducing it here, it's just the square root of 1. And then 1 times 2 is 2. That would be -3/2. So I'm writing into this one. Over here, 1 to the 3/2 power means that I take 1 to an exponent of 3, which would be 1 times 1 times 1, which is still 1. Square root, I still got 1. So if I subtract, I've got -3 minus 1, which is -4 over 2. All of this, I get g prime of -1, or of 1 is -2. So, because I want a g prime of 1. So if I want to know what is the slope of the line tangent, this is it, the slope of the tangent line. If I want to know what is the slope of the line perpendicular to the tangent x equals 1, all I would do is take the opposite reciprocal. So that would be positive, and instead of 2 over 1, I'm going to say 1 over 2. Okay, next problem, even though I went into this a little bit in the first one. And the first one, if the line tangent to the graph of the function at 3, 8 also passes through this, -3, 2, then what is f prime of 3? Okay, let's think about this. F prime, this is the derivative at x equals 3. I can also think about this as the slope of the tangent at x equals 3. And if I know 2 points on a line, I know that the line tangent to the graph has a 0.38 and -3, 2. I can find the slope of the tangent line because going way back to y2 minus y1 over x2 minus x1, that was an algebra 1 thing that you did probably quite a lot. Here's my first x value, my first y value, second x value, my second y value. And then I just do this. I just take 2 minus 8, y2 minus y1, over x2 minus x1. And you should make sure that you do it correctly because I almost said -10. 2 minus 8 is going to be -6. -3 minus 3 is -6. My slope of the tangent is 1. Don't go further than that thinking that you have to. You're good. That's it. So if you need to give yourself you can't really give yourself one high five, but if you need to say, wow, that was pretty easy because I'm really smart, feel free to do that at that point. Okay, next one. It's pretty early at my house right now, if you can't tell by some shadows on here, so I'm trying to be fairly quiet while my youngest son is sleeping. Okay, in number 3, if the graph of the function f of x is concave down, okay, so concave down at x equals 4. So what I want to do is if I'm talking about concave down, I'm just going to draw it, concave down, and it could be any part of this. It could be over here, but remember concave down. Oh, so sad. It's like a frowny face. If I wanted concave up, it'd be like that. And it doesn't mean it has to be at the maximum or the minimum. It could be over here in this part of the function, or over here, over here, or over here. But let's do this one first. If f of x is concave down, would the tangent line approximation of f of 4.1 be an over or under approximation? Okay, first, if we were actually finding a tangent line approximation, the very first thing you have to do is find the equation of the tangent line, get a slope and a point. This problem doesn't have any of that. It's just saying I'm making up in my own world. If I have, let's say, 4 over here, and this is the graph of f of x. This is my x-axis, and here's 4. So this is where the function is touching the, this is the point of tangency, for where the tangent line and the function touch. At 4.1, and I'm going to exaggerate this, say it's really zoomed in, would be over here. It's probably going to be much, much closer. But if I exaggerate and say it's over here at 4.1, is this an over or under approximation? This, you see how the tangent line is above the function? So this is an over approximation. If f of x was concave up, so x equals 4, I'm just picking a spot, x equals 4 could be over here or over here, but if I, ooh, that was a good tangent line. Ooh. Okay, so hopefully your tangent lines are as good this morning, but if this is 4.1 here, and again, I'm exaggerating it, it would be much, much closer. And this is kind of bad. It's kind of hard to see because it went straight up. But in this case, you can see that the function value is way up here, and this tangent line is way down here. If we're talking about f of x is concave up, this would be an under approximation. Okay, moving on. For number 4, the limit as h approaches 0. Hey, this looks like the limit as h approaches 0 of f of x plus h minus f of x over h. And I know that all of this is just the derivative. It's just the definition for derivative. And so what I can do here is I can say, instead of doing this long way, which, oh man, that would be so bad, what you can do is just pick out, well, what's f of x in this problem? F of x plus h minus f of x, I know it's over here. So you don't make it negative because there's already a minus here. So I know in this function, f of x is cosine of x. And what I want to find is f prime. The derivative of cosine is negative sine. That's it. Don't go through some long way in order to finish, well, in order to do that problem, just at all. There's not very much room in here. It's not because I messed up, it's because I don't want you to do it a long way. That would be very, very hard, and you'd have to remember a whole lot more than the derivative of cosine is negative sine. Move on. Number 5, this equation represents the tangent line to the graph of g of x when x equals 2. What is g prime of 2? Again, this is the derivative at x equals 2, which means it's the slope of specifically at x equals 2, slope of the tangent line, which means I want to take the equation of the tangent line and I want to simplify this so I can tell what the slope is. So going way back to algebra 1, I'm going to put in the form y equals mx plus b, or close to that, so that I can figure out what the slope of that line is. So I'm going to distribute the 7 and get 7x plus 28. I'm going to add 4 on both sides. So I get 3y is equal to 7x plus 32. I'm going to divide by 3. So I've got y is equal to 7/3 x plus 32/3. Y equals mx plus b. I found the slope of the tangent line. That is g prime of 2. G prime of 2 is 7/3. So you're trying to figure out, you're like, okay, well, what does the derivative mean? This is the equation of the tangent line, and if you haven't figured this out, you need to know that the derivative is the slope of the tangent line. So work on that. Okay, the next one, it says the graph of the derivative of the function is shown to the right. So if it's the derivative of the function, and it says it down here, but it's teeny tiny and you don't want to mess it up. So this is f prime of x. It's saying the graph has horizontal tangent lines at x equals -1, x equals 1, and x equals 3. Really, it's just saying this is where the maximum is happening, this is where minimum is happening, this is where maximum is happening. But be careful, this is of the graph of f prime. It's just telling you a little bit more about the graph. If this messes you up, like, you know what, I'm gonna cancel or cross this out. Just because it's not telling you where mins and maxes are, it's not telling you where horizontal tangents for f of x are, just on f prime. This says list everything now I know about f of x. If we're talking about, let's even just say about horizontal tangents, I'm going to say f of x has horizontal tangents, and it's not going to be at x equals -1, x equals 1, and x equals 3, because that's where it's happening for f prime, it's going to be at -2, x equals 1, so one of them is the same, and x equals 4. Or really close to 4. It's kind of hard to tell if that's it or not, but for the sake of this, we can say it is. So f of x has horizontal tangents to that value. And the reason is, as f prime of x is equal to 0. So pick the places where f prime is equal to 0. Okay, if we're talking about increasing, decreasing, max, mins. So I'm going to say f of x is increasing. And I'm going to justify first so I know where to look. That's where f prime of x, the slope, is positive. So I'm going to go up to the graph, and I can see positive and negative. So positive above the x-axis, negative below. So from -2 to +1, I can see that's happening where it's above. At 1, f prime of x is equal to 0. And then I've got 1, 2, 4. Okay, so I've got f of x is increasing where f prime of x is greater than 0 from -2 to 1 and 1 to 4. And sorry, I was a little bit distracted because I can hear Pokemon playing right now. So I'm going to ask my son to turn it down, and then I'm going to keep going. Caleb, turn it down, please.
Can I interrupt your video?
Okay, and now back at it. So, I know you guys have to take breaks too to turn down Pokemon videos. So f of x is increasing where f prime of x is greater than 0. Slope is greater than 0, so you're just looking about where is this above the x-axis? Where is f prime above there? Same thing if I did decreasing, well, similarly. I'm looking for where f prime is less than 0, that would be below the x-axis. This one, you can see that the graph stops, so it doesn't have an arrow then, so I'm just gonna say from -3 to -2, and then 4 to 5. If these had arrows on the end, then you would say from -infinity here and +infinity here. The other ones are, you need to find a relative max and a min. So relative mins for f of x occur when f prime changes, and so if I'm talking about minimums, they go here to here. So when f prime changes from a negative slope to positive, I'm running out of room, so I'm gonna abbreviate, but negative, well, no, I'm not, 'cause I wanna make sure I'm a good example. So negative to positive. I can see negative to positive. I'm going from negative to positive right here at x equals -2. And then right here, because I'm running out of room, it would be the same thing. You would say relative max for f of x occur when f prime changes from positive to negative. It's changing right here from positive to negative. So at x equals 4, that's where a relative max would occur. At x equals 1, it's neither a min or a max because I'm going from positive to positive. So that means that on the graph of f of x, there's something happening where you're going positive and then positive some more, but somewhere there's a horizontal tangent. Okay, moving on a little bit more. I know this is long, but hopefully you're skipping through to the parts that you need. And number 7, it's here. Picture to the right is the graph of h prime of x, so this one's labeled. So I have the derivative. List all the things you know about h of x, so super similar. So I'm gonna go through the things that we need about h of x. H of x is increasing. H of x is decreasing. H of x has a relative max. H of x has a relative min. So these are things that I generally look for in the graph. I might talk about horizontal tangents too. We'll see. Okay, so h of x is increasing. So with knowing that I have to justify using h prime, when h prime, I want my slope to be positive, so h prime has to be greater than 0. Decreasing, I want the slope to be negative, so h prime is less than 0. Has a relative max. This is going to be at a specific point, and this is going to happen when the slope changes from positive to negative. So the function is changing, increasing to decreasing. I'm going to say when h prime changes from positive to negative. H of x has a relative min when h prime changes from negative to positive. Okay, so if I'm talking about h of x is increasing when h prime is positive, all I'm looking at is when this graph is above the x-axis. This is hard to see. Let's put arrows on the end of this so I can just say to infinity, because, you know, I'm a boss and I can do that. But if it wasn't, you'd have to know. It would say, like, what intervals you're going to, like maybe until 4 or maybe until something else. But I'm putting arrows on here. So I see from 3 to infinity, h prime is above the x-axis. From negative infinity to negative 2, from negative 2 to 3. So I'm stopping at negative 2 because h prime of x equals 0 at that point. There would be some big debate of whether to say that this is strictly decreasing, and there's some arguments around this at negative 2, but I'm just telling you because I want you to recognize that at negative 2, h prime of x is equal to 0. Go from negative infinity, negative 2 to 3. A relative max happens when h prime changes from positive to negative. If I look here and I'm like, okay, I'm going to do this, and I'm reading left to right, positive, 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 there's a positive here, but there's no negative afterwards. I have to say, because I'm saying all the things I know, I don't see a place where that happens. So what I'm going to say is h prime or h of x does not have a relative max when, and then I'm going to do as h prime of x does not change from positive to negative. It's a little messy, but I'm hoping you get the point. The last one, h of x has a relative max when h prime changes from negative to positive. If I go over, this is negative, but it stays negative. So right here, there would be a horizontal tangent for h of x, and actually for h prime, since it's also a maximum on this graph, but that's just, you know, good fun to notice. Negative to positive, if I go over here to x equals 3, that's when that happens. Okay, last one for number 8, the graph of the quartic function. So quartic function just means it's like x to the 4th power somewhere. That's the highest exponent. P of x is pictured to the right. So here's P of x. So that's nice. I know this one was the derivative. This one is just the original function. So different questions are being asked. First question is, I want to know on the intervals when P prime of x is less than 0. And I'm going to do the same thing that I did above, and I'm going to justify first. So I'm going to say when P of x is, so the slope is less than 0 when P of x is decreasing. Next one, P prime of x is greater than 0, so meaning the slope of the tangent is greater than 0 when P of x is increasing. P prime of x is equal to 0, so the slope of the tangent is 0 when P of x has a horizontal tangent. Or I could also say, because a lot of times this is happening when a function is going from increasing to decreasing, or P prime is changing from positive to negative or negative to positive. So I could say when P of x has a horizontal tangent or relative extrema, meaning mins or maxes. Okay, first one. So P prime of x is less than 0 when P of x is decreasing. So I'm looking for all the places reading left to right, decreasing. I can see they happen here and here. So from 0, because I'm doing my x to an x value. It's from 0 to 2, and from 4 to infinity. Increasing from negative infinity to 0, and then 2 to 4. And then the last one, p prime of x is equal to 0, and p of x has a horizontal tangent. I can see this right here, right here, right here. So I would say at x equals 0, x equals 2, x equals 4. Make sure you go through this list of topics for the quiz 3. I write these down when I'm looking at the quiz, so they're usually pretty helpful, or at least that's what I think. So on this, it's having, a lot of these are things that we already did, so just that I did practices a little bit ago. But analyze f of x and f prime of x in intervals for f of x increasing or decreasing. But the ones that we did on here were mainly graphs. Make sure that you're good with tables and equations. So if you were given an equation on free response, that you're able to take the derivative, you're able to set up the chart yourself, you're able to then justify correctly. So make sure that you're able to do this in any of those forms. So go back, look at homework, make sure you're okay with that. The next one, if it talks about coordinates or relative minimums or maximums, you find the x value, and then you go back up to the original f of x, and you substitute the x to find y. So if it's talking about coordinates, that's always points from the original function. You won't be asked for points for f prime or f double prime later. So right now, you're just, if you want coordinates, make sure you plug back in your x into the original function value, f of x. For tangent lines approximations, you have to know if a function is concave up, is the tangent line greater or less than? That's the one that we did in the first example if we're talking about concave up versus concave down. But go over that again. Make sure that you've really got that. This is a big one. Rewrite function with negative and or fractional exponents, because I realized that that's the struggle more so than taking the derivative, is just changing around the function. You need to understand the derivative is the slope of the tangent line, but I'm hoping that's in your head. Minimum, maxima, oh, this says maximu. There's maximums, maxima, but there's no maximu, unless maybe that's like a height of a herd of cows or something. I don't know. It's super early. I've got to get my jokes on point yet. But intervals of increasing and decreasing. Know that this, the limit as h approaches 0, just means f prime of x. So you can always take this thing, the f of x, take the derivative of that part. This, similarly, means the f prime of a. So you could always take whatever the function is at f of x, take the derivative, and then the thing that was substituted here, this a. So if it was like f of 3, and you can see what 3 was substituted, you would find f prime of 3. So, quiz 3, it's coming up. Prepare well. Ask me questions if you have questions over the weekend, or just sometime when you can't come in and see me. Remember that you can send me pictures of things that you're struggling with on Remind, and I will respond as quickly as you can. I think Ian just woke up